All right, so again, yesterday we introduced ourselves to trigonometry, which again, a lot of you said you already had at least an intro course with the geotrig. So we'll keep rolling with that guy today. So yesterday we covered 1.1 and 1.2. Today we're going to cover 1.3 and 1.4. So if I share my screen with you guys here quickly. All right, there's only 4 lessons in this first unit here. So for today, we're going to cover 1.3 and 1.4. And 1.4 is the review of all of Unit 1 and also includes your test here. All right, so we'll probably cut class short a little bit today to give you some time to work on this during class time. Okay, so we'll cover 1.3 and 1.4 today, and then we will be done. Okay, so again, our goal every day is to cover about 2 units here. All right, hopefully you guys were able to do these first 2 quizzes here. So we had the first one on right triangles, and then the next one was on angles and radians. All right, so now we're gonna move forward to this thing called the unit circle. All right, the unit circle. And really the unit circle is a circle that has a radius of 1. So yesterday we dealt a lot with looking at radians and what it means. Again, a circle, the circumference of a circle is 2 pi r, right? So when we were dealing with radians, we understand that it's 2 pi r as the entire circle, r being that radians or radius, right? So when we're dealing with radians, it's 2 pi for the entire 360-degree circle. All right, we call it 2 pi radians. And again, we were able to do some basic calculations where we could figure out, okay, if this is what my angle is, this is what my arc length is, based on what you have. All right, so now we're gonna look at this unit circle, and a unit circle is specifically when it has a radius of 1. Okay, a radius of 1. And that's gonna be super helpful for us. All right, so again, our trigonomic functions, those are your sine, cosine, tangent, cotangent, cosecant, and cosine. No, sorry, secant. Sorry, secant and cosecant. Those trigonomic functions that you guys said you dealt a lot with, all right, those are gonna come back into play here with our unit circle, all right? Especially because those trigonomic functions helped us to determine and define angles between 0 and 90 degrees, right? Or if we're talking in radians, that's 0 and pi over 2 radians. And again, just to remind you here, let me see if I can draw it without it looking. Oh, yes. Okay, so if this is our circle, again, the entire thing is 2 pi. So if the entire thing is 2 pi, if I split this, nope, very close. All right, if I split this, all right, sorry, assume that that's perfect in fourths. If I split this into pies here, right? If I split this into pies, so this would be my starting point. This would be 0 pi, right? And 180 degrees would be 1 pi, right? Come back around, this would also be 0, or it could also be 2 pi. All right, so my 90 degrees is pi over 2. And this would be 3 pi over 2, right? 3 pi over 2. All right, so sorry, that would be 3 pi over 2 for my 270 degrees. All right, and again, that's because this entire thing is 2 pi r, right? And so for, again, our unit circle here, r equals 1, right? So this is what we're gonna be dealing with here, okay? This is what we're gonna be dealing with here, just to keep that as a reminder. All right. So moving forward here. All right, if we review our functions, I know you guys dealt a lot with this, so we'll go through it quickly. But to review the functions here, remember that's SOHCAHTOA, sine, cosine, tangent. Right, so if we look here, for our tangent, right, that's TOA, right, opposite over adjacent. Oh, and I'll turn my sound off for a second so that doesn't keep going out. Okay, opposite over adjacent for my tangent. Okay, for secant, that is the inverse of cosine. So cosine is usually adjacent over hypotenuse. So now it's hypotenuse over adjacent. All right, and what is adjacent over opposite? All right, adjacent over opposite. So we're dealing with either tangent or cotangent, right? And so adjacent over opposite would be cotangent. Right, that would be cotangent, right? Because TOA, T-O-A, would be tangent equals opposite over adjacent. All right, hypotenuse over opposite, right? So if it starts with hypotenuse, that means we are dealing with one of our inverse of our original three functions. So hypotenuse over opposite. So that would be, if I had opposite over hypotenuse, that would be sine. Okay, so if we take 1 over sine, we're dealing with cosecant. All right, and then finally, adjacent over hypotenuse. Adjacent over hypotenuse. That would be just a normal sine there. Or sorry, cosine. Normal cosine. All right, so now we've got that refresher out of the way. If we are looking here, we're trying to look at our unit circle. Again, our unit circle has a radius of 1. All right, and we understand now that this whole thing is 2 pi. We understand that 180 degrees is pi, so between 0 and pi is obviously pi over 2, right? And then between pi and 2 pi, at 270 degrees, halfway would be 3 pi over 2, right? This would be 3 pi over 2, okay? So now what we're going to do is we're going to talk about and expand our knowledge here about what happens when we have angles between pi over 2 and this 0 pi, right? Or between 0 and 90 degrees. So we're going to look at this redefining trigonometric functions using our unit circle.
Starting at the right side of the unit circle, move along the circle T units to the point P.
Okay, again, remember, this is talking about our arc length, so we moved it arc length of T to this point P, right? And I don't want you to get confused. This is not a function. This is just saying point P, and it's located at some value of X and Y. All right, so if you can't tell here, we're on just a normal graphing grid here. So again, this line here is our X axis. This would be our Y axis, right? So if we drew our unit circle perfectly on, perfectly at the origin, right, it would be 1 unit in all directions when it crosses any of the axes. That's what makes it have that arc length of, that radius of 1. Okay, so it's saying just move up to some point P between 0 and 90 degrees, and it's going to be located at point X, Y.
This is called the terminal point. If you draw a straight line from the origin to the terminal point P, you create angle theta. Remember that by measuring the angle in radians, you can easily relate arc length T to the measure of the angle.
Okay, again,
if you draw a vertical...
Sorry, I thought I hit pause.
If you draw a vertical line, arc length T to the measure of the angle.
Okay, so remember, this is what was done in the last unit that we talked about yesterday, okay? But since this is a perfect unit circle here, whenever we get our angle, right, we would have to calculate that in terms of radians, and then we would multiply whatever our angle is in radians times by whatever the radius is. Now, since this is a radius of 1, because we're dealing with the unit circle, it would just be whatever our angle is in radians, okay? Whatever our angle is in radians.
If you draw a vertical line down from point P, you form a triangle with angle measuring theta radians.
Okay, And what you can see here now is that if we have a right triangle, remember now we can use our sine, cosine, tangent, all of those different functions, and we can figure out the different lengths of our legs, and effectively we can figure out where this point is, right? Because if I go over distance x, right, that's my leg right here, that's my adjacent leg. And if I go up y, that's my opposite leg. All right, so looking at this here, if I have sine of theta, I've got opposite over hypotenuse, so y over 1, which is effectively just like saying y. And I've got my cosine, which is my adjacent over my hypotenuse, so x over 1. It's just like saying x, right? So this point here, again, is located at xy, or you could also say the point is located at cosine theta, comma, sine theta, because that's what x and y equal.
With the definition of sine and cosine based on the unit circle, you can now redefine all 6 trigonometric functions.
And again, the rest of those then come from understanding, okay, if this is sine and this is cosine, well, tangent is sine over cosine. Cosecant is 1 over sine, right? All the rest of the 6 functions. Okay, so now that we understand that, and let me get rid of my drawing here to make way for new drawings. Okay, so now that we kind of grasp that, we can see that again, sine of theta on a unit circle between 0 and 90 degrees, sine of theta is going to equal the y coordinate. Okay, sine of theta is going to equal the y coordinate. And cosine of theta is going to equal our x coordinate, right? And again, it's if we were to draw a straight line here, straight down from this point to our axes, right? It's not the entire length, it's point to the axes. And then obviously we can solve the rest of them here. And I do like they put the little disclaimers here. When x is not equal to 0, when y is not equal to 0, right? Because you can't have an undefined function or something where you divide by 0, right? So again, this is going to be on that study sheet for you to fill in, but it's super, super important here. All right, so those are good ones to remember. At least remembering sine and cosine, right? So sine would be y, cosine would be x. After you have those two, you can quickly solve for the rest of them. All right, so now here, if we look at some new definitions of our trigonomic functions, we can follow this.
Now you can explore these new definitions by marking some particular points on the unit circle and seeing what the value of each trigonometric function gives you. Remember that the angle in these equations is measured in radians from the rightmost point to the terminal point.
Okay, so looking here, what is the value of theta for this point, right? Trying to figure that out. So the terminal point is located at the rightmost point, okay, all the way over here. So that makes this 0 radians, right? So this would be 0 radians, right? Because the whole thing is 2 pi radians, so we start off with 0. Okay, so if we know that this is at 1, 0, okay, we know that we have 0 radians, okay, and we also know that now using our new functions, we know that, we know that sine of theta is equal to y and cosine of theta is equal to x, right? So another way of saying this is sine of theta equals y becomes sine of 0, right? And if you have your calculator out, as long as it's in the correct mode for radians, right? When you type in sine 0, it will give you out 0, right? If you type in sine 0 on your calculator, it will give you a value of 0. But if you type in cosine 0 on your calculator, it will give you out the value of 1. All right, so you can always double check using your calculator. But if you understand that this process and you understand that sine equals y, you don't have to do that, right? You can just pick this up quickly. And then knowing that sine of y is equal to 0 and sine of 0 is equal to 0 and cosine of 0 is equal to 1, you can figure out the rest of the functions here. And again, some of them, whenever you have to divide by this 0, it becomes undefined. It becomes an undefined function. All right. So then looking here, if we understand again, this whole thing is 2 pi. What's the value of theta for this? That's going to be pi over 2, right? It's going to be pi over 2. Or what they did is they said, okay, the whole thing is 2 pi. Well, what's 1/4 of this circle? Okay, it's 1/4 times by 2 pi. So pi over 2. All right. So now if we understand that this angle is pi over 2, right? What we can say is again, we still know that sine of theta is equal to the y coordinate and cosine of theta is equal to the x coordinate. All right, so we know that. But what we can say here when we're filling in our values is that sine of pi over 2 equals 1, right? That's my y coordinate. So sine of this angle gives me my y coordinate. Cosine of this angle, right, gives me my x coordinate. Well, I didn't move anywhere, so that's 0. So then again, following through with the other 4 functions, we can solve or write as undefined. Okay, so that's going from 0 all the way to 90, right? We can figure those out. But now what happens if we go beyond that, right? Beyond that, we have again this value of pi. Okay, so pi. So again, typing in sine of pi is equal to 0, right? Because we didn't go anywhere in terms of up and down, right? This coordinate's at -1, 0. So if I'm not even looking, if I'm just looking straight here, I can tell you that cosine of this angle is going to be equal to whatever my x value is. So cosine of pi is going to be equal to -1. Again, solving the rest of them using the processes that we know. And then finally here, we've got 3 pi over 2. Okay, 3 pi over 2. Same exact things, all right? Same exact things where sine of this angle 3 pi over 2 is going to be my y, which is -1, and cosine is going to be 0. Again, if this is difficult for you, try to remember at least that cosine of theta equals x and sine of theta equals y. You can always 1000% plug this into your calculator as long as you are particular. All right, as long as you're careful of how you plug this in, it should give you the same thing. All right, knowing again that you're in the mode of radians. You have to be in radians if you're dealing with things in terms of pi. All right, so if we summarize here, if we summarize our unit circle, okay, we're dealing a lot with zeros, ones, negative values, and undefineds. All right, and it's asking you, see if you can find any patterns. Well, the 2 patterns that I can pick up here are if you look at 0 and 180. If you look at 0 and 180. Oh, that was supposed to be a straight line. Apologies. Wow, an awful lot of straight lines apparently. Okay, so if you look at all right, 0 and 180. You're going to notice that they have the same undefineds. They have the same 0 values. The only difference is that when it's a positive 1 for one, it's a -1 for the other. Look, +1, -1. All right. So if it's positive for one, it's negative for the other. And believe it or not, the exact same thing happens with 90 and 180. If it's a +1, it's a negative for the other. +1, negative for the other. All right. So those are some quick patterns that I picked up on, right? And again, you can figure out that yes, when we're dealing with things that were straight up and down, that's when you have a value for sine. When you're dealing with something on the x-axis, right, that horizontal axis, that's when we're dealing with values for cosine, right? So some things like that. All right, But if we want to go beyond just those 4 basic points, right? We want to go beyond those 4 basic points. We can find different values using this process we're going to learn here.
You are going to continue to build the unit circle by concentrating on the first quadrant. That is the part of the circle where x and y values are positive. To do this, you can use what you know about the ratios of the sides of some special right triangles.
Okay, so again, quadrant 1 being over here, right? If we were labeling these quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, but we're focusing here, and like you said, it's where x is positive and where y is positive, right? Or remember we were talking about infinities. This is positive infinity and negative infinity, or sorry, positive x infinity and positive y infinity. All right, where on the unit circle is the terminal point? So where's the end point for pi over 4? Well, pi over 4 is going to fall halfway between pi over 2 and 0. Right, so it falls halfway between those. Okay, what will the x, y coordinates for this point be? Right, and that's where we'd have to solve them, right? That's where we're going to have to solve them. We're going to have to look at our sine and our cosine. So if I were to draw this triangle here, right, if I were to draw this triangle, since I cut, right, I cut my original 90-degree angle, right? If I went from 0 to pi over 2, that would make a 90-degree angle. But I cut that in half. So this angle here is actually 45 degrees when I make my new right triangle. This is 45 degrees. All right? This is 45 degrees. And if you don't remember that, or you didn't know that off the top of your head, you could do our very simple conversion here that we learned yesterday. Right, so to go from radians to degrees, you just take whatever your radians is, so pi over 4, and I multiply by 180 degrees over pi radians. Right, radians on top would cancel with radians on bottom, and I'm left with my 45 degrees here. All right, and then what we learned yesterday, or reviewed yesterday, was it's a 45, 45, 90 triangle, right? So knowing this, the legs of the triangle are going to be this square root of 2 over 2. Okay, the square root of 2 over 2. All right, so since both of these legs of a 45, 45, 90 triangle, we know that they're going to be square root of 2 over 2. So that's what our coordinates are going to be, right? We already know this off the top of our head because it's one of those special triangles. So our x and y coordinates are both the same. It's the square root of 2 over 2. And I guess let me back that up here for a second. Oh, I can't. But remember, if you didn't know that off the top of your head, you can always go back through the process that we did. So if you had your right triangle here, right, you could go back through the Pythagorean theorem, a squared plus b squared equals c squared, and solve, right? You could solve. And since it was a 45, 45, 90, we know that both legs are going to be the same, right? So we kept those as the same variable, right? So again, if you don't know these off the top of your head, it's not the biggest deal in the world. 1, you can look them up. 2, look on your study sheet. Or 3, go back through the process which we originally did to find them, which is the Pythagorean theorem. All right. Now, if we look here, pi over 6, again, pi over 6 is going to be somewhere between pi over 2 and 0 or 2 pi. All right, so it's going to be in this first quadrant still. And what you're going to find out is it's going to be a third of the way up. All right, it's going to be a third of the way up. So pi over 6 is 1/3 of pi over 2, right? Great. So it's going to be a third of the way up. And hopefully you can kind of guess what this angle would be, right? Since it's a third of 90, it would be 30 degrees. 30 degrees, right? Or, again, do your conversion factor. Since it's pi over 6 radians, we multiply by, again, 180 over pi. That gives me my 30-degree angle. Okay, I get my 30-degree angle right there. So again, now we have a special 30, 60, 90 degree triangle, right? We have a 30, 60, 90 degree triangle. Since we have that special triangle here, okay, since we have that special triangle there, all right, we are then able to remember that we have our two different sides. Okay, so our longer side, which is our x coordinate, is this square root of 3 over 2, and our shorter side is this 1/2. Our shorter side is this 1/2. And again, if you need to, remember, go through the entire process. We had that process of cutting that 60, 60, 60 triangle in half, which is how we know that this shorter length here is that 1/2. All right, so our coordinates here are going to be square root of 3 over 2, comma, 1/2. All right. So continuing this process here, if we did this for pi over 3, we follow the same process, okay? Except this time it's 2/3 of the way up. So either doing our conversion or knowing what 2/3 of 90 is, we know this is going to be a 60-degree triangle. All right? And since, again, it's the same thing, we just flip now the x and the y coordinates, right? So now we have 1/2, comma, square root of 3 over 2. Right, so we just flip our x and our y coordinates for this, but it's still a special 30, 60, 90 degree triangle.
Putting it all together, you have the coordinate locations of several more terminal points and their corresponding angles. This will allow you to solve some trig equations using their definitions. Take a look at some examples.
Okay, so again, now that we have these major points here, these major points, we can then solve, like you said, these trigonomic equations. Right, so regardless though, we know that cosine of theta is equal to x. It's equal to x. So if I have cosine of pi over 6, I go to the location of pi over 6. What's its x coordinate? Oh, it's square root of 3 over 2. It's square root of 3 over 2. So the answer there should be square root of 3 over 2. Right? So now that we have, again, pretty much these 4 major points here, right, in this quadrant 1, we have 4 major points. It's going to make it a lot easier for us to be able to pick up on some of these trends here. All right. So now that we understand at least generally, right? We understand those major points, okay? We understand those major points. We can now use them as references for points around the circle, okay? Because again, that's the beauty of a circle, right? Especially a unit circle. It's all going to be even. It's just going to depend on which is a negative sign and which is a positive sign, right? So we're going to be able to use this thing called reference angles, and those are those ones that we just came up with in quadrant 1. Okay, so it's reading that this is a good start for building up terminal points using the unit circle by matching the coordinates on the unit circle with their corresponding angle, right? And since we can do that, we're able to solve so many trig functions without actually using a calculator, all right? Without actually using a calculator, we can solve a lot of these trig functions, okay? So we can solve a lot of these now with the majors without having to use our calculator by knowing these, what we're going to call reference points. Okay. So then we haven't looked at the other quadrants though. Okay. So is there a way to use the points that we've already found in order to solve the other quadrants? And the answer is yes, right? Yes, of course there is. It's a circle. Okay. So we're going to call them our reference angles, our reference angles. Okay. So by that, what it means here is if I look at 5 pi over 6, I look at 5 pi over 6. All right. It's in quadrant 2, so it's in the second quadrant. We can still make a right triangle with the point. So if we were to make a right triangle, it would look like this, right? We would make a right triangle, and we would notice that it compares to, right? It compares to another triangle that we know, which is pi over 6, right? It looks like pi over 6, except it was just reflected across this y-axis here, all right? So it looks like pi over 6, but just reflected across the axes. So you can see that the sides are the same, right? The lengths are the same. The only difference here is that now instead of having a positive x value, we're going to have a negative x value, right? The values are still the same. The absolute values are still the same. However, we're now in this second quadrant where the x values are negative, right? So what we can say is that pi over 6 is a reference point for this angle of 5 pi over 6. All right, 5 pi over 6. And the easiest way that I remember it, look at the denominators. They're the same, right? Pi over 6, 5 pi over 6. As long as 5 pi over 6 is in its simplest form, its reference point is going to be pi over 6. All right. Oh, sorry. So looking at another one, okay, you can use this trick to find more terminal points, right? So we can use these reference points to find more terminal. We just need to be able to match the angle with its reference angle in quadrant 1, right? So if we were to look at this guy here, this is our original, and we were trying to figure out what's its reference angle. Well, we make our right triangle, okay, we make our right triangle. You make our right triangle and we're able to then solve. But what this guy was saying here is you need to be able to match the reference angle with its angle, great, from quadrant 1. And then it's saying the reference angle for any real theta is determined by the shortest distance between the terminal point and the x-axis. All right, so again, it's always the terminal point to the x-axis. So we're going to draw that line straight down. Okay, and then oftentimes you'll know the coordinate associated with the reference point, but maybe not the terminal points. Okay, so you'll know the reference and you can connect what the x and y values from the reference are to what you have in your specific quadrants by, again, changing the positive and negative values. So if we look here at our original, we know that we're going to draw our line straight down here, okay? And we know that its reference point in quadrant 1 is also going to look the same, right? It's reflected across that y-axis if we're in quadrant 2. All right, so again, it's always matching the closest distance to the x-axis. All right, so again, the trick here is that the coordinates will be the same, except for they may have a negative sign. So you're going to have the exact same absolute value, but they might have a negative sign now in place. All right, so if we look here at this example, we've got 4 pi over 3. 4 pi over 3. Well, the first question is going to be, what's its reference angle? Well, again, looking at its denominator, it's over the denominator 3. And since 4 pi over 3 can't be simplified, its reference angle is going to be pi over 3. Right, and if you don't believe me, you could always draw your reference angle, right? So you can measure the angle between the terminal point and the x-axis, and then you can do the exact same thing in quadrant 1. So terminal point to the x-axis, all right? And what it's saying here is that you can subtract it from pi. Since this is pi here, we would go 4 pi minus 3. Minus the pi, right? So its reference angle, again, is pi over 3. All right, it's pi over 3. So you can, again, draw a straight line if you'd like to match that up, or the method that they walked through that I didn't read out to you as it was going, okay? You can measure the angle between the terminal point and the x-axis. So the angle between the terminal point and the x-axis. Well, if our x-axis here, this point is pi, okay? So this entire angle is 4 pi over 3. So what we can do is we can take 4 pi over 3 minus pi, okay? Because we're gonna just looking for this part in green. So if this entire thing is 4 pi over 3, we can subtract pi from it. So we can subtract pi to just get out this green part. So that gives us our pi over 3, which is going to be now our reference angle. All right, it's going to be our reference angle. And so we now know that this is the coordinates for our reference angle, and looking at where we are at in our coordinate, on our coordinates, okay? We are in this quadrant 4 where x is negative and y is negative. So the only thing we're going to do to these reference points to make them fit this 4 pi over 3 is we're going to make them now both negative. So this is going to be negative 1/2 and negative square root of 3 over 2. All right, the coordinates associated with this 4 pi over 3 are both negative. All right, so again, the key for this is going to be knowing your reference angles. After you know your reference angles, everything else is either going to be a positive or negative version of your reference. Okay, so again, this is going to be beneficial for you. Beneficial for you. Same thing here, right? Knowing that anywhere on a unit circle, if I have an angle, okay, sine of that angle is going to be its y coordinates. Cosine of that angle is going to be its x. Tangent's going to be y over x, and then so on and so forth. All right, so if we're looking here, sine of 3 pi over 4. Sine of 3 pi over 4. Well, we know its reference angle is going to be pi over 4. Okay, we know its reference angle is going to be pi over 4, except for now it's got a negative x value. So this is going to be negative square root of 2 over 2, and then positive square root of 2 over 2. So we're looking for sine of this value. Okay, we're looking for sine of this value. So sine is going to be the y coordinate. So since we know it's over here, it's going to have still a positive value. So that should be positive square root of 2 over 2. All right. So looking at this again, we found our reference angle. Great, we found our reference angle, and you can do it by knowing that if it's got the same denominator, it's going to be the same in the reference. Or what they did was they said, okay, 3 pi over 4, we're trying to get it to pi. So what's pi minus 3 pi over 4? Well, that's pi over 4. All right, so that's our reference angle. Knowing that this is our coordinates, knowing that this is our reference angle, okay, this now becomes negative square root of 2 over 2, and the positive y value, okay? Since we're looking for sine, again, we're still looking for our y value, okay? We're still looking for our y value, and our y value is this positive square root of 2 over 2, right? So without doing anything, right, without plugging it in a calculator, we figured out that it's going to be this square root of 2 over 2, okay? And the reason this is going to be important here is because if an answer asks for an exact value, all right, an exact value, if you plug this in your calculator right now, right, and I can do it for us all, right, so if I have sine of 3 pi over 4, in my calculator, it doesn't give me out this cute little nice value of square root of 2 over 2. It tells me 0.070710678, like that, blah, 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 blah. It keeps going on and on and on and on. All right? So you can't just plug it into your calculator and get out this nice square root of 2 over 2. All right? So when it's asking you for an exact value, you're going to have to know the reference angles and be able to write it in this form that you're seeing here. All right. Now, if you want to check yourself, okay, this is always a way to check yourself. I plugged in, like I said, I plugged in sine of 3 pi over 4. It gave me a positive value, right? And what I can do then is, okay, I know first off, this is a positive value, so I'm halfway there. I can just plug into my calculator, square root of 2 divided by 2. And it's going to give me out the same value as when I typed in sine of 3 pi over 4. All right, so you can always go and check yourself, but if it's asking you what's the exact answer, or if it's asking you to type in an answer, right, it's going to ask you it in this nice, neat form here. All right. So one more example, I'll let you guys do the third one here on your own, but for this practice example here, it's asking you what's the cotangent of 5 pi over 3. So first off here, you got to figure out what is its reference angle. Okay, so 5 pi over 3 is somewhere around here. All right, we know its reference angle is going to be pi over 3. Once we know its reference angle, okay, we know its x and its y coordinates. We now then just change anything we need to become negative. This is still in the positive x direction, so this is still going to be positive 1/2, but it's now in the negative x direction, or sorry, negative y direction. So this square root of 3 over 2 is going to become negative, right? So now I have my negative value. All right, and it's asking me for the cotangent. Well, the cotangent is going to be cosine over sine. So it's going to be x over y. Okay, so it's going to be my x coordinate over my y coordinate. X coordinate over my y coordinate. So my 2's end up canceling each other out. And what I'm left with is the negative 1 over square root of 3. All right, 1 over square root of 3. All right, there is a third one here, and I'll let you work that one on your own or for your homework to check yourself here. Okay. So again, this is what your full circle would look like if we filled in all of those major points. Okay. But realistically, all you need to know is the first 90 degrees. Because once you get the first 90 degrees, everything else is a version of that, right? Again, it just depends on if it's negative or positive. I turned it off. There it goes. All right. So again, if you look here, it's just interactive. And what it's showing you is, okay, these are my reference points. Okay, these are my 3 reference points. And if I go over here, that's its reference point. Same thing. Okay, so you could go here and just look at how are these reference points. And again, you're going to find out it's the same shape of triangle. It's just reflected across one or both of the axes. Okay. So then we're looking at our study guide here, Okay. So trigonomic functions are sometimes called circular functions. Okay. And that's because if we go to the unit circle, we can then, and I'll skip over those. If we go to the unit circle, we can use them to solve for our coordinates, right? And get an exact value. So sine of theta is equal to y and cosine of theta is equal to x, right? And the rest of these, again, are some version of that, depending on their relationships, okay? This is that table that we filled out for our 4 major points, 0, 90, 180, and 270. Again, either being 0, 1, 0, 1, 1, 0, negative, whatever, right? All of that stuff, okay? Then here, these are our reference angles, the 30, 45, and 60 degree angles. Okay, those are our reference angles. And based on our reference angles, we can then determine the rest of the angles. Okay, we can determine the rest of the angles. Okay, and again, this is based on the unit circle. Okay, and I personally don't like this or this as much as I like this one, or even just the one with the 90 degrees. Okay, so if this is confusing to you, by all means, take a picture of something along the lines of this or earlier in the unit. Okay, to me, this is more helpful, but to have all the exact values, this table is also necessary. Okay, so you can use this, like I said, you can use this, whatever is going to help you. I personally prefer this guy here. All right. If we keep going on here, yes, we finished. Perfect. If we keep going on to our study, we have another quick study in this unit before we get to our checkup. But this one should not be anything you super new. All right, this is just an extension of Pythagorean theorem. So I'll skip over this quickly. But a squared plus b squared equals c squared, right? We know that. And we know that our x coordinate now is our cosine and our y is our sine. All right.
If you draw in the line connecting the point xy to the x-axis, you get a triangle. You also know the lengths of each of the sides of this triangle.
Okay, so we now know, again, x and y is either sine and cosine, and yes, we can get exact values if we know what our theta is. But we can also do something a little bit more interesting.
Now, what does the Pythagorean theorem tell you when it's applied to this triangle? Plugging in the appropriate trigonometric functions for x and y, you get cosine squared plus sine squared equals 1.
Okay, so what it's saying is if I look at my triangle up here, a squared plus b squared equals c squared. Okay, this is my x coordinate. I can say x squared plus y squared, and that's going to give me my c squared here. All right, but c squared we already know is 1. And since we already know that x squared is cosine of theta, we know that x is cosine theta and y is sine theta, we can change that and say cosine squared plus sine squared gives me my hypotenuse, which is 1.
This equation represents a very important relationship between sine theta and cosine theta for any real number theta. You will use this equation many times before this pre-calculus course is over. It is also an equation that you will use frequently when you study calculus. So, a word to the wise, learn this relationship.
All right, so again, all it's saying, and it's a slightly different form of seeing it, is we still say it's sine squared, right? So this is sine squared of theta, or sine of theta squared. Sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. Right? And when you plug this into your calculator, unfortunately, you can't plug it in this notation. All right? So you would have to plug in sine of your value, hit enter, and then take your answer and square your answer. All right, so again, being really careful, you can't type it in this function directly as you see it in your calculator, unfortunately. All right. Again, moving forward, connecting it to the unit circle. Okay, so again, a unit circle, we've got x squared plus y squared equals 1, and we know that, right? And so now we know that cosine squared plus sine squared equals 1. All right. So this relationship is going to be important moving forward. We're going to be able to use it. So we're just kind of introducing it here now that we're talking about our unit circle. All right. And what happens if I decide to divide everything by my cosine squared? If I divide everything by cosine squared divided by cosine squared, that gives me 1. Sine squared divided by cosine squared, well, what's sine over cosine? It is tangent. Okay, so I've got tangent squared, and then I've got 1 over cosine squared, or 1 over cosine. Well, that's secant, so I can get secant squared. All right, so this is another relationship here. So if I have 1 plus my tangent squared, I can get secant squared. All right, if I decide to divide everything by sine squared, well, cosine over sine gives me cotangent. 1, and then 1 over sine is cosecant. Right? So I have now a third relationship. So these 3 are known as Pythagorean identities. All right, Pythagorean identities. All right, and we're going to use these more moving forward here. But these are really, really helpful because anytime we can plug into an equation and solve without actually having to use our calculator is always a great time. Right? It's always easier if we have an identity that can kind of give us a shortcut rather than having to do all of these things. Okay? So those are our Pythagorean identities. All right, so pretty much that's the summary of this little 5-slide study. Okay, your Pythagorean identities, your equations, and the Pythagorean theorem in general. Okay, I'm not even going to go to the study because that last slide was basically the entire study guide. All right, so then looking here at our checkup. Okay, looking here at our checkup. To show that a point is on the unit circle, okay, it's wanting you to use one of those new Pythagorean identities, right? Or what it's saying is you have to prove that x squared plus y squared equals 1, right? Because it's on the unit circle. It's on the unit circle. So it has to have a radius of 1. It has to have a radius of 1. So if I take my x component and I square it and I add it to my y component squared, according to Pythagorean theorem, that should give me my radius squared. So if I do this, does it give me 1? And the answer is yes. Yes, it does. Okay. So you'd have to solve like that. For a couple of these, it's asking you to explain your logic. How do you know the reference angle is what it is? How do you know the reference angle is what it is? And to explain how you know that. All right. This one here is saying if it's on a certain point in the unit circle, okay, how do you know what is y? Or how do you know what is x? Right? And the key there, the key is going to be able to pay attention to, it says third quadrant. It says second quadrant, right? So looking here, if we look at this first one, all right, if it lies in the unit circle, P is in the second quadrant, okay? It's in the second quadrant. So we know if we're in that second quadrant, well, X is immediately got to be negative, all right? It's in the second quadrant. It's got to be negative. Then we just plug into our equation of x squared plus y squared equals 1, right? So x squared plus our value for y squared equals 1. We can just solve for x, right? We solve for x. And then again, like I said, we know it's in the second quadrant, so we know that value has to be negative. All right, we have to be negative. Then we'd have a couple problems here. It's asking you to find the reference angle, right? And then tell us the terminal points, okay? So again, that's all based on the reference angle. This one's even easier because it's all based on pi over 4. It's all based on pi over 4. This one's based on pi over 6, pi over 3, pi over 2, right? All of that fun stuff, okay? Then again, you're going to answer, it says what's cosecant or what's cosine of these values. Okay, so again, you're going to have to find the reference angle, figure out what its x and y coordinates are, and then you would have to figure out, again, if this is asking for cosecant, that's 1 over sine. So that's going to be 1 over y, right? All of that kind of stuff. Right, so hopefully not anything too difficult here. The ones that I find personally most difficult, give an example of a real number theta for which cosine is positive and sine is negative. Okay, so you're going to have to first think about, well, where on the graph would that happen? If cosine is x and sine is y, where would x be positive but y be negative? Right, so you're going to have to then find a value that would fit this, right? So you could find an x value that fits this, or find a y value that fits this. Then you'd have to use the identity of x squared plus y squared equals 1, and then solve for your other value. Okay, solve for your other value. Okay, so hopefully not too terribly difficult here. All right, so this is the one quiz you have to do, okay, before you get to this final unit here. So this wrap up, okay, this wrap up. And again, the practice and discussion are extra credit opportunities if you want to take it. All right, they're extra credit opportunities if you want to take it. If not, not a big deal. But again, not that many extra credit opportunities this time. Okay, so extra credit if you do either or both. And then you are only going to be required to take this CST, right? The computer scored test. We are not taking the teacher scored tests, right? So only the computer scored tests. All right. Taking a quick look at the review here. Again, I would suggest you try these. Okay, I would suggest you try these. This first one here is going to ask about what are the different angles, right? If it measures 90 degrees, it's a right angle. Is it obtuse? Is it zero? Is it straight? Reflex? All of that stuff. Okay. This one here for conversions, that's reminding you about going from just the degrees to that degree, minute, second form, right? Degree, minute, second form. Remembering that there's 60 seconds in a minute and there's 60 minutes in a degree. Okay, and then this is also talking about converting from radians to degrees and degrees to radians. All right, this one here is talking about, again, sine, cosine, tangent, all those identities that you guys worked a lot with already. Okay, this one's giving you a table of actual values. So if I've got 0 degrees at 0 radians, what are my identities? Okay, it's giving you that entire table. And that becomes important because now we're dealing with the unit circle and our reference angles. Okay, so understanding that our reference angles are between 0 and 90, and we can use them to solve any of the other angles with similar properties. Okay, and we just change either the negative or the positive sign. The big one here I want to focus on is calculator mistakes. Okay, go through and watch this, but the biggest 2 calculator mistakes you can make here are not being in radians or degrees, depending on what you're trying to solve, okay, and not being particular with the order of operations. Okay, order of operations is going to be huge. All right, so just to give you a quick calculator review, switching between radians and degrees, okay, that's just hitting that mode button, right, and making sure the cursor's highlighted on either degree or radians, depending on what you need, okay? The other one is going to be is if you need something like cosecant, okay, we don't have that function, most of us, unless you bought a very advanced calculator here, all right? We don't have that function. So in order to do that, you're going to have to type in 1 over sine of theta, right? And what they suggest here for looking at secant is 1 over cosine. So if you're asked to find secant of 155, the first thing you'd make sure is that you're in degree mode, okay? Then you would type in cosine of 155. You'd hit enter. And then you would take 1 divided by your answer. All right, so that's what they recommend. Or just, again, being very, very, very particular with parentheses and how you're typing it into your calculator. All right, so you can do that for all of your different modes here. All right. And just to highlight a couple things on the practice that I think could be very, very helpful. All right. Scrolling down. Okay, giving exact values, right? So again, exact values means you have to put it in square root of whatever form. So if this was square root of 2 over 2, you have to write it like that. You can't write it in decimal form. All right. Talking about, is it an acute angle? Right? Is it acute? Is it right? Is it obtuse? Knowing your different angles are going to be helpful. Okay? Taking a minute to actually convert into your your decimal minute second form. Okay? That's going to be helpful. Again, if it has the 1 tick mark, it means minute. If it has the 2 tick marks, it means seconds. It means seconds. All right, converting between radians and degrees. Hopefully we're all good with that. It's just basic unit cancellation. All right, and then your word problems. Okay, your word problems. Picking out what you know or what you need to know, right? And then finding an equation that fits it. All right. Hopefully not too terribly difficult. I would suggest at least taking a look at this and maybe trying 1 or 2 problems. 1, you can get some extra credit point, right? We do offer partial extra credit point. But then 2, you're just more prepared for your test here. Okay, so it's about 11 o'clock here, and we're going to end class right now.